Hello and welcome to the lesson on the universe beyond our solar system. What I'd like you to do first is have a think about and write down some of the names of objects or celestial bodies that make up our solar system. And if you can, also have a think about what a light year might be. So in today's lesson, we're going to have a recap on what objects make up the solar system and have a look at the difference between comets and asteroids. Then we're going to have a look at how the universe is organised and have a look at galaxies and stars and a few things like that. And then towards the end, we're going to have a look at what a light year is and how we can actually use that to measure some distances in space. So following on from the starter activity, you might have made a list of some of the things that you think are in our solar system, and there's a few blanked out words and numbers here for you to have a go at seeing if you can work out. So pause the video and see if you can work out what's under these missing question marks. Okay, so in our solar system we have actually got one star which we call the Sun. We have got 8 planets, we've got 5 dwarf planets, and we've got lots and lots of moons, over 200 moons within our solar system, and lots of asteroids and comets. So we're going to have a look at what all of these things are today before we go on to looking at the wider universe. So we've got our 8 planets in the solar system, which I'm sure you're already aware of, and you've learnt about the order of the planets from the Sun to out towards Pluto. Pluto did used to be a planet, but a while ago it was reclassified as a dwarf planet for a number of reasons, but one of the reasons being that it was quite small compared to the other planets. Another reason is that its orbit was a very strange orbit compared to the orbits of the other 8 planets that we've got in the solar system, so it was declassified and reclassified as a dwarf planet. You can see the size of it here compared to the Moon. There are some other dwarf planets that have been discovered as well in various different places. There's one here called Makemake, which is named after some mythology from the people of Easter Island, and it means great sea spirit. There's Ceres here, which is in the asteroid belt, which we'll talk about a little bit later on. It's a very, very large lump of rock. It's also classed as a dwarf planet. So compared to our 8 main planets, the dwarf planets are in orbit around the Sun, but they're much smaller and some of them have some strange orbits. Now there are lots of moons in our solar system. You can see here it says we've got more than 200 moons, but this diagram here just shows some of the major moons. We've got some of the moons of Jupiter up here, some of the famous ones, or the most famous one is Ganymede. It's a very large moon of Jupiter. We've got the most famous moon of Saturn, which is called Titan. Some scientists, astronomers are thinking that there might possibly be life on Titan, even though it's not a planet, it's a moon, because they think that possibly underneath the surface there might be some hot springs that might be able to support life. So scientists are looking here on Titan for possible life in the solar system other than on Earth, because as it stands there's no other life being discovered other than on Earth. So we've got Earth's moon here. Earth's only got one moon. Jupiter's got, I think, 69 moons or something like that. So lots and lots of moons orbiting Jupiter. And then we've got some of the others down here. So the dwarf planets have also got moons as well. So there are lots of moons in our solar system. And a moon is something that orbits around a planet, whereas a planet is something that orbits around a star. So asteroids and comets are things that can be found in our solar system, and what we'd like you to do is just pause the video and write down anything you already know about asteroids and comets and see if you can say what the differences are, and then unpause the video and come back for the information. Okay, so asteroids to start with. Like the 4 inner planets, they are made from rock, and most of them are orbiting the Sun between the orbits of Mars and Jupiter. So we call this the asteroid belt, and this is where most of the asteroids are sitting. They can be quite small. They can be meters in diameter, but they can also be really large. They can be kilometers in diameter. Ceres, which is one of the dwarf planets, is actually in the asteroid belt. It's over 900 kilometers in diameter, so they do range quite a bit in size, but they're made from rock, and most of them sit here in what we call the asteroid belt. If we compare those to comets, comets are made from dust and gas, but quite a lot of that is in the form of ice. It's because it's very, very cold. So when they get close to the sun, they start to melt a little bit, and you get this characteristic view of the comet when it gets close to the sun, because you can see it. Otherwise they are normally quite dark, but because the ice melts, they get this tail called the coma, and that always points away from the sun. So as the comet orbits around the sun, the coma will always point away from the sun, but sometimes this means that they are visible to us. But because they can take a very long time to orbit, some of them take over 200 years to orbit the sun once, we don't get to see them that often. So if we do get to see them, it's quite a special event. And the orbits are very elliptical, and this is another reason why they are so difficult to see or to come across, because they spend a lot of time quite far out in the solar system, and then they get closer to the sun and we can sometimes see them, and they're normally a few kilometers in diameter, so you can see that there are a few differences between them. So I said on the previous slide that comets have a very highly elliptical orbit, so I just thought I'd include this slide as well to show you what I meant by that. So if you compare the in this animation, the orbit of the Earth, it's circular or almost circular around the sun. It stays the same distance away during its orbit, whereas you can see with the comet, it comes very close to the sun and then it goes very, very far away. So this is an ellipse, and it's very elliptical because it goes very, very far out, and it takes a long time to actually orbit the sun once. And as you can see again from this animation, that as the comet gets closer to the sun, the tail becomes more visible. So the melting ice that turns into gas starts to reflect the light from the sun, which means that you can see where the comet is much more easily. But when it gets far away, it gets colder, and the ice stays as ice and it doesn't melt, so the comet becomes quite dark when it's far away from the sun. Something else to say as well is that as the comet gets towards the sun, because it's closer to the sun, the gravity is having much more of an effect. It accelerates, it starts to go faster, so it kind of whips around the sun and then slingshots back out into space for sometimes hundreds of years. Okay, so now we've had a look at the solar system in detail, we're going to have a look at what might be beyond the solar system and have a think about what's included in the whole of the universe. So pause the video and have a think, can you jot down some other objects that we might find in the wider universe that are outside our solar system? Okay, so here are some of the things that you might have come up with. There are other stars which make up galaxies. There might be some other planets that are out there orbiting other stars that we call exoplanets, and they might also have moons. And you might have come up with, if you've done some background reading, that there is nebula out there, which is the place where stars are formed. You might have come up with dark matter, which is said to be making up quite a lot of the universe. So I don't know if you've got any of these, but if you did, well done. So now what I'd like you to do is have a look at these objects, some of which you will be familiar with, and I would like you to try and put them in order, starting with the smallest. So pause the video, have a go at putting them in size order, and then unpause the video and find out the answer. Okay, so hopefully this is the order you came up with, Moon being the smallest, followed by planets. Even though that doesn't include dwarf planets, because some of the dwarf planets are smaller than our moon. Then after that you would have stars, then the solar system, which is made up of these things plus the other stuff, and then solar systems and other stars form galaxies, and then the collection of galaxies then forms the universe. Okay, so the next question you might be wanting to ask is, what actually is a star? And you can see here we've got quite a complicated diagram in the background. But what I'd like you to do is pause the video and just write basically what you think a star is, and then you can unpause the video and come back for the information. Okay, so hopefully you've had a bit of time to think about what a star is, but in short, they are very large balls of gas. I've put in here that they're not burning, they're not on fire, because a common thing that people say is that the sun or a star is a huge burning ball of gas, or it's a big fire, but that's not actually true, because stars aren't on fire and they're not burning. That's actually something to do with chemistry, whereas this is really a physics topic. It's actually something called nuclear fusion, where the gas that's in the stars is fusing together and producing lots and lots of energy. So the second point here is that stars are radiating lots of energy by light and by heating. There's other forms of radiation as well that stars will radiate and give off that we can't see and we can't detect, and we can use special equipment to find out about that. But again, that is something that you don't really need to know at this stage. If you do pick to do triple science when you get to the end of year 9, then you will learn a lot more about stars and a lot more about the life cycles of stars and how they are formed and how they sort of live their life, if you will, and then how they die, and the different kind of stars that you can get is quite complicated, but it's very, very interesting. And that's something that you will look at, like I said, if you pick triple science when you get to the end of year 9, ready for year 10. It's saying here as well that they may seem dim when we look at them with the naked eye or even with binoculars or a telescope, but they are actually really, really far away. So it's not that they are small or that they are dim, it's just that they are giving off light, and that light is coming from very, very far away, so they may seem to be small and dim. And as I said before, they do have life cycles and they last for a very, very long time, and that's something that you might learn a little bit more about at GCSE. Now, when we look out into the universe, we can see that stars are organised into these big clusters of billions of stars called galaxies. And the galaxy that our solar system is part of is called the Milky Way. And it's important to realise that our sun and our solar system are very, very small within this galaxy. Our sun is one very small star in a collection of billions of stars, and our solar system orbits around our sun, which is actually one of the smaller stars that we know about. We think that the majority of stars are actually larger than our sun, and they are thought to be organised in a spiral galaxy. Our galaxy, the Milky Way, is thought to be a spiral bar galaxy, which is kind of like a flattened disc shape with these arms where you've got lots of stars concentrated on these arms. And it's thought that we are kind of about here, sort of 2/3 of the way down one of the arms. We don't actually know exactly what our galaxy looks like. We can only really guess from the information we've got. And the reason for that is that we can't actually get anything far enough away from Earth and far enough away from our galaxy to actually take a photograph of it, because it's just too far away. So I thought I would add into this that actually this is not a picture of the Milky Way. We don't actually have any pictures of our galaxy because it's not possible to get out of our galaxy to actually take the photograph. Now, we can't photograph our own galaxy, but we can photograph some of the other galaxies in the universe using powerful telescopes, and here are a few examples. You can see that different galaxies have different shapes and different sizes, and actually it's important to know that the galaxy itself is rotating, so all of these stars and the solar systems that orbit the stars are actually orbiting what we call the galactic centre, so the centre of each galaxy. Some are thought to have very, very massive black holes at the centre, but it's important to know as well that as the solar system is orbiting the star and its solar system is actually orbiting around the centre of the galaxy. And it's thought that there are 1 to 200 billion galaxies in the universe, and that each galaxy contains around 100 billion stars, so that's a lot of stars. Okay, so have a look at these images and see if you can write down what they are called. You might even be able to name one or more of them, so have a go at that. So these are the star constellations that you might be able to see on a clear night. Probably the most famous one, where it's a toss-up really between these two. Orion is quite easy to find in the night sky, especially in winter. You've got these 3 stars in the middle that make up Orion's belt. The Plough you might have heard of. In America they call it the Big Dipper, and that's actually part of a larger star constellation called Ursa Major, which is the Great Bear. There's also Ursa Minor as well to be seen. One thing that I think is important to recognise about these constellations is that they make up patterns in the sky as we can see them from Earth, but these stars aren't actually close to each other. They are very, very, very far away from each other. So they do make a pattern in the sky for us to see, but they aren't actually close to each other. These animations here show how the stars appear to move in the sky. They appear to rotate around a single point, which is around about where the North Star is, what we call it. It's shown on this animation here. You can see where the North Star is, and all the other stars appear to rotate around it, but actually this effect is caused by the Earth spinning on its axis, as mentioned in a previous lesson. So as the Earth spins, our view of the sky changes, so it appears that the stars are rotating around in the sky or moving around, but actually it's the Earth spinning on its axis that causes us to see this effect. Okay, so now it's time for you to pause the video and do some activities. So the first activity here, which everybody should do, is to complete these sentences. So for the first one, a star is, so I want you to complete that sentence so it makes sense based on what we've done so far in this lesson, and do the same for the other 4 sentences. There's an extension task here for you to draw a diagram to show how the universe is organised, so some way of showing the universe organisation and what things, objects are present in the universe that we know about. And there's an alternative challenge activity here, which is to describe 3 differences between comets compared with asteroids, comets compared with stars, and galaxies compared to solar systems. So have a go at these activities and then come back for the information. Okay, so I'm going to go through the answers and you can check what you've got and see if you need to make any corrections or any edits or add any extra information. So for the first one, a star is a huge ball of gas that gives out lots of light and heat energy. So that's the first one. The second one was we can see the sun but not the stars during the day because the sun's closer to the Earth, so it appears much brighter than the other stars. So the other stars seem dim, but it's because they are much further away. And we can't see the light from the other stars in the day, but of course we can see the sun and the light from the sun because it's much closer. For number 3, constellations are a group of stars that make a pattern in the night sky. You could have added the extra information about the fact that those stars aren't actually close to each other, they just appear to make a pattern from where we are on Earth. Number 4, stars seem to move across the sky because the Earth's always rotating or spinning on its axis, which causes us to see the stars moving across the sky, but actually they're not moving. And then the last one, a galaxy is a collection of billions of stars, and of course solar systems and their moons and things like that, and they're all orbiting around the centre of the galaxy. Our solar system is a very, very small part of a galaxy that's called the Milky Way. Okay, so now's the time to pause the video and see if you can write a definition for light year or any other information that you know about light years, and you can look at this lovely picture of the Lovell telescope at Jodrell Bank while you do that. It's really, really important to know that a light year is actually a measure of distance and not time. Quite a lot of people get confused because the word year is in there and the year is an amount of time, but a light year is actually a measurement of distance and not a time. So that's the first thing. The actual definition of a light year is the distance that light travels in 1 year. So the reason why we need to use light years is because the distances would be such large numbers and it would be a lot to write down. It's more convenient to use light years because the light year will be a much smaller number to use when you are talking about distances in space. The distances in space are very, very big. So the speed of light is 300 million meters per second, or 300,000 kilometers per second. So if we just have a think about that, how far it's going to go in a year, we've got it travelling 300,000 kilometers every second, and in a year you've got more than 31.5 million seconds. So if we work that out, in a year light's going to travel this very large number, which is 9,460,772,580.8 kilometers, which is a lot. So here it's basically saying that light is going to be travelling 9.46 trillion kilometers, and that's the same as 5.88 trillion miles. So that's a pretty large distance, and it's just more convenient to use light years to tell us distances in space compared with using kilometers. So there are some objects that are relatively close to Earth. Now we know the moon is not that close to Earth, but relative to some of the other objects in space, it's quite close rather than being trillions of miles away. So if we have a look at the Earth and the moon, the distance here is 1.2 light seconds, which means that it takes 1.2 seconds for light reflected off the moon from the sun to reach us. So when we look at the moon, we see how it looked 1.2 seconds ago. So there's a little bit of a delay, which is not going to make that much difference because, like we said, the moon is relatively close compared with some of the other objects that we look at in space. So if we compare that with the sun is 8.3 light minutes away from us. So that means it takes 8.3 minutes for the light from the sun to reach us on Earth. So again, we're seeing the sun how it looked 8.3 minutes ago, but please don't look directly at the sun because that is extremely dangerous. Moving a bit further away, if we think about a star called Proxima Centauri, that is the nearest star other than the sun, so it's the next one along. It is 4.22 light years away, so that means it takes 4 years and 3 months for the light from Proxima Centauri to get to us. So when we observe this star, we're looking at it or seeing it how it was 4 years and 3 months ago. So if something changes, it's going to take that long for us on Earth to be able to see that change. So even further away, we've got the Andromeda Galaxy, and the Andromeda Galaxy is the closest galaxy to the Milky Way, and it's thought to be moving towards the Milky Way, and it's on a bit of a collision course. So eventually, the Andromeda Galaxy and the Milky Way galaxy are actually going to collide. It's 2.5 million light years away. So when we observe the Andromeda Galaxy, we are seeing it how it looked 2.5 million years ago. So the likelihood is that it's actually changed quite a bit since we last looked at it. And this is the main problem with observing the universe. The further away the object is that we're looking at, the more it's going to have actually changed, and we're seeing it how it is in the past. So if we think about it the other way around, if we are being observed by some other intelligent life form, what are they actually seeing? It really does depend how far away they are as to what they're actually seeing, because they're not going to be able to see us in the present day, they're going to see us in the past. So worth thinking about. Okay, so to finish off the lesson, I want you to pause the video and see if you can answer this question. It's not really a question, but explain why it's useful to use light years to measure astronomical distances or distances in space. Also, make sure you've got the definition for light year written down because it's an important definition to remember. Okay, so hopefully you've had a chance to have a go at this, and the main points to make really are that first of all, that light years measure distance, and it's the distance that light travels in 1 Earth year, so making sure that you know what a light year is, and that distances in space, if we measured them in kilometres, would be extremely large numbers. So we use light years, and that means that the numbers that we deal with are smaller and more manageable than trying to use very large kilometre distances. Okay, so that concludes the lesson on the universe beyond our solar system. Hope you enjoyed it and found it useful, and I'll see you next time.